Alright, this video is going to be on finding roots, and I apologize in advance for how long I'm anticipating it will be. So the first thing that I think is important is to know the vocabulary. So x-intercepts are something that you're often asked to solve for. Roots, zeros. These are all the exact same thing, but they have different notations that are important. So an x-intercept, anytime you're ever asked to find an x-intercept, your answer should always be written as a point. Always, always, always. With roots and zeros, it is more common to see people write x equals and then say what the number is, so that's okay. And then you'll also have problems where they say to solve for x. And I'm including that just because the process for all of these is the same. Even though the directions might be a little different, the process is really similar. So anytime it says to solve for x, or you have roots or zeros, you can go ahead and write x equals as your answer. But if I see it asking for an x-intercept and you don't write it like a point, you're technically wrong. So just be careful of that. Okay, the first thing we're going to look at is real roots. That's going to take up the majority of the video. So these are going to be the actual roots that you see when you graph your calculator, when you graph a function on your calculator. And the first thing, we're just going to review a lot of factoring because that's typically how we're going to find them. So the first type of factoring we're going to look at is the GCF. And so this would be a problem like y equals x squared, 3x squared minus 9x. And you would replace the y with 0 because we're finding roots, which is where the y coordinate is 0. And a GCF, you're just looking for what's in common. So each of these has a 3 in it, and each of them has an x. So I'm going to go ahead and take that out, and then I'm going to write what is left over. So 3x squared divided 3x would leave just with an x left over. Negative 9x divided by 3x would be negative 3. So if we are solving here, we've got this x should equal 0, and that x should equal 3. And again, if the directions, well, the way I labeled it, I said we were looking for roots. So since I said roots, we're able to just write it like that and call it good. Alright, the next method is of factoring I call the diamond method. You might not have called it that before, and if you didn't, that's fine. I'm not going to be upset about it. So here they're going to write something like y equals x squared plus 11x plus 30. So again, setting that equal to 0. And the diamond is just when you're saying I want to find something that multiplies to 30 and adds to 11. That's all it is. So the two numbers that do that are 5 and 6. So when I write this in factored form, I would say, alright, I've got x plus 5 and x plus 6, and that equals 0. And so my two solutions here, I would have x equals negative 5 and x equals negative 6. Alright, I'm going to do another sample of the diamond method where the x squared term has a coefficient. So this is going to be 2x squared minus 7x minus 15. I don't know if you can hear that in the video, but it's like thundering really loud outside and pouring, which means I'm about to get caught in the rain. Alright, so when we do this, anytime you have a coefficient here, you actually multiply these two numbers together. And I'm going to factor this a way that I think you have probably never seen before. It's called grouping. And the reason that we're going to do grouping is not because it's like better or anything, but it's because it shows up in calculus. And this is pre-calculus, so it'll be good for you guys to be exposed to it at least. So 2 times negative 15 is negative 30. And then, so we're multiplying to negative 30 and adding to negative 7. So the two numbers that would do that would be negative 10 and 3. So what I'm going to do is I'm going to keep that 2x squared, and I'm going to keep the negative 15, but the negative 7x I'm going to split into these two, because if I write negative 10x and positive 3x, then that equals negative 7x. So it's like I'm splitting it. So now I have 4 pieces. So what I'm going to do is I'm going to factor these in groups. That's what factoring by grouping is. So I'm going to split it down the middle, and then I'm going to factor this part with a GCF. So we've got a GCF of 2 and x, and so that leaves an x minus 5. And then over here we have a GCF of 3, and that's it. And we've got x minus 5, and that was a positive 3. And so now if you look at this, what happens is we have 2 sets of parentheses that are exactly the same. So if you can picture this as like this is one thing and this is another thing, then the GCF of these two would be that x minus 5 parenthesis. So if I take out the GCF, and what's left over is the 2x from this one and the plus 3 from that one. And again, there are other ways to do that, and you might have even done those other ways in the past, and the only reason we're practicing this is because you will see it in calculus, so we just want to make sure you're familiar with that. So the first solution would be x equals 5, the second solution x equals negative 3 over 2. Now sometimes, I called this a diamond because I did a diamond to get there. Sometimes you'll see a problem where it won't look like this in the original. It will just have, like, you'll have something that's got 4 pieces. Typically, if you see a problem that has 4 pieces like that, you can try to factor by grouping. Okay. The next way that I'm going to remind you of is difference of squares. So our example here is y equals x squared minus 25. And if you guys recall, difference of squares is pretty easy. You have 2 sets of parentheses, one with a plus, one with a minus. And then as long as these 2 terms are something squared and you have a minus in between, so difference of squares, as long as that is the case, then you can take the square root of this, and that's x, and the square root of that, that's 5. And that's your factoring. It only works, though, if it's set up like this. So then our solutions would be x equals negative 5 and x equals positive 5. Okay. This next type of factoring is actually brand new to you, and this is the sum and difference of cubes. And so when you see sum and difference of cubes, we're actually going to have a formula for factoring this. And that's going to be a to the third plus or minus b to the third. So that's like what the original function would look like. And if it originally looks like that, then when you factor it, it's going to be a plus or minus b. And then here's going to be a squared. And then this part you're going to write minus or plus. You're going to switch those, and I'll tell you why in a second. And then it's going to be ab plus b squared. Okay? So, the way that it works is if you see a plus here, then you're going to use the plus there and the minus there. So you would focus on the top operation, and then this is always a plus. If you use a minus here, then you would use a minus here and a plus here and a plus there. So the way that we memorize this is, so if you start off with a plus and this is the same, this is the opposite, and this is always positive. So soap. So that's how I remember that. Okay, so here's our example on this one. We've got y equals 8x to the third minus 27. And the first thing I need to do is figure out what my a and my b are so that I can plug them into this formula. So I'm going to rewrite this problem as 2x to the third, so that's 2x times 2x times 2x is what would have gotten us to here, minus 3 to the third. So now I know that my a is 2x and my b is 3. So now I can use it in the formula. So I go same, so same sign. And then I do a squared, so 2x times 2x is 4x squared. And then I do opposite, so the opposite sign is a plus. I do a times b, so 2x times 3 is 6x. And then I do plus b squared. Alright. So this first one is the easiest one. That's x equals 3 over 2. This part is not always, but is often something that cannot be factored, and the solution here is typically a complex number, almost always, which would mean we have to do the quadratic formula, which is perfect because that was the next thing I was going to do anyway. And so we'll go ahead and do the quadratic formula example, and we'll just do it as in finishing this problem. So we're going to have one more answer up here, and we're going to write it after we have used the quadratic formula to solve this problem. So next is quadratic formula. Which, if you don't remember, is negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. And we're going to go ahead and do this for that previous problem. So we are using 4x squared plus 6x plus 9. That's what we're going to do it on. Okay. So we're going to have negative 6 plus or minus the square root of 6 squared minus 4 times a times c, all divided by 2a. And I'm not going to try to plug this all in my calculator because I know that since it's from the difference of cubes, it's most likely going to be imaginary. So I'm just going to simplify this. Alright, so now if I plug this part into my calculator, I'm going to get negative 108. Alright. So the first thing I usually like to do is I'm like, well, I can't have that negative right there, so I'm going to put an I in the front. I know that's imaginary. And now we have to do some real fun, that simplifying of radicals over there. You can do a factor tree if you would like to. You don't have to. Whichever method you have for doing this. I'm just going to look at perfect squares. So 36 divides into 108, and it goes in 3 times. So this could be written as the square root of 36 times the square root of 3. And the square root of 36 is 6. So now I'm just going to go ahead and replace that part of the equation. So I've got negative 6 plus or minus, and I've got, don't forget the I, so I've got 6i square root 3, and that's all over 8. And then if you notice, all of these are even numbers, which means I can divide by 2 on all of those. So the final solution here is that x equals negative 3 plus or minus 3i times the square root of 3 divided by 4. And so I'm going to go back up and I'm going to put that answer on my previous problem. Alright, next we're going to go ahead and do completing the square. So for the first one, and we're going to have to do 2, I'm sorry, just because the processes are kind of different depending on if you have a coefficient or not. So for completing the square, again I'm going to say that this equals 0. And most students are more comfortable in this process having it on the right, so I'm going to go ahead and move it there. So in completing the square, the first thing we do is we take the plane number, we move it to the other side. And then we take the x term and we divide it by 2. So 8 divided by 2 is 4, and 4 squared is 16. So I know that to complete the square I need to have a plus 16 right here. And if I have a plus 16 that I just added on the left side out of nowhere, I also have to add it on the right side. So what that leaves me with now is on the right side I've got 11. On the left side, if I was to factor this, I'm looking at 2 things that multiply to 16 but add to 8. That's 4 and 4. So this is x plus 4 squared. And if you guys remember from when you learned how to complete the square, whatever you get when you divide by 2, that 4, that's the number that goes in here. So you can kind of shortcut that step. You don't really have to factor it. So from here to solve, all I need to do is just get the x alone. So I'm going to go ahead and square root each side. So I have x plus 4 equals, and I'm going to be really careful here since I took a square root to solve that. It's plus or minus the square root of 11. And then to get the x alone, I'm going to subtract 4 over. So exactly, if I'm looking at what it exactly equals, it's plus or minus the square root of 11 minus 4. And then if I want to find those approximate answers, I can do that. I just have to type this in the calculator. So square root of 11 minus 4 is negative 0.683. Negative square root of 11 minus 4 is negative 7.317. Alright, we're going to do another completing the square problem. So this one we're going to do a coefficient with the x squared. So again, I'm going to start off by making it equal 0. And just like the other time, I'm going to move that plain old number to the other side, because that's what we want. And here we have one extra step. So what we're going to do now is we're going to take that 2 out, x squared plus, take the 2 out here, so 10x. And so now we can complete the square on this, and it kind of looks like the other problem did. So now I'm going to do 10 divided by 2 is 5. 5 squared is 25. So the number that will complete the square here is 25. But I didn't just have one set of the parentheses, I actually had 2 sets of the parentheses. So I really did like 2 multiplied by 25. I really added 50 to the left side of the equation. So now on the right side of the equation, I have to add 50 as well. Alright, so I've got the 2 in the front. My parentheses are going to have a 5 in them, so x plus 5 squared equals 61. So now I can go ahead and I'm trying to get the x alone from there. So I've got x plus 5 squared equals 61 over 2. Square root each side. So I've got x plus 5 equals plus or minus the square root of 61 over 2. And then I can just subtract that 5 over. So 61 over 2, subtracting the 5 over. And again, you can plug it into your calculator to get those approximate answers. So 0.523 and negative 10.523. Okay, and then the last way for real roots we're going to say is graphically, so like not even doing it by hand, just plug that sucker in your calculator, and then you would hit on your graphing calculator second trace. And when you hit second trace, the menu comes up, and then you would do number 2, zeros, right, because you're finding the 0 of the graph. And I'm not going to do an example of that because I think you guys should probably remember how to do that. Okay. So that is it for real roots. So now we just have one example of how to find complex roots, and I know this video is super long and I'm really sorry. So finding complex roots. How's that for a straight line? Pretty good, huh? Alright, so the first step when you're finding complex roots is to find the real roots graphically. Because and the reason we're doing that is because typically this is going to be a function it's more than a quadratic. Usually it'd be like a cubic or even higher. So you'd find the real roots graphically because you probably will not know how to factor it, and then if it has complex roots it's probably not factorable anyway. So and then after that we're going to use synthetic division. And once you're done with synthetic division, you will probably have to use a quadratic formula. So that's like the breakdown, if you guys remember how to do these. Okay, so on this problem, we're going to go ahead and find all of the roots, the real roots and the complex roots. So 2x to the fourth minus 5x to the third minus 29x squared minus 73x minus 30. Okay, and I went ahead and plugged it in on the calculator already. This is what it looks like. So we have a real root here and a real root there. So if I do second trace number 2, and I'm looking for this one, so I've got left bound, right bound. It's at -1/2. So I've got -1/2. This one over here, it looks like it's at 6. So I'm just going to double check that it's at 6. Plugging in 6. Yes, it's at 6. So I know that my two real roots, x equals -1/2 and 6. And then I'm going to put a comma because I have a couple more there that are complex that I'm about to find. So when you do synthetic division, you can start with either one of these. It does not matter. So I'm going to go ahead and do 6 just because it's a nicer number. So, and I've got my coefficients here too. -5, -29, -73, and 30. If you guys remember synthetic division, you drop down the first number, and if this is truly an x-intercept of the graph, then our final remainder should be 0. So just watch for that. So I drop down the 2. 2 times 6 is 12. -5 plus 12 is 7. 6 times 7 is 42. -29 and 42 gives you 13. 6 times 13 is 78. When I add these together, I get 5. And then 5 times 6 is 30. Sorry, this was -30. Okay, I was like, that adds to 60, not 0. Alright, so we've got that. So now we have to do synthetic division again using the -1/2. So -1/2, and I keep the 2, and the 7, and the 13, and the 5. So drop down the 2. 2 times -1/2 is -1. That gives you 6. 6 times -1/2 is -3. That gives you 10. 10 times -1/2 is -5. And that gives you 0. So we found the real roots, we used them in our synthetic division. Now we have to take what's left over and write it as a quadratic. So this is 2x squared plus 6x plus 10 equals 0. Oop, there it is. Okay. Alright, so now these are going to be complex roots, so that means that this is not factorable. It's definitely a quadratic formula problem. See how all these numbers are divisible by 2? You can divide out 2 now, and that will solve you, or that will save you from having to divide out 2 after you have done the quadratic formula. So I would go ahead and do that, is just divide the whole thing by 2. So I've got x squared plus 3x plus 5. And now we can go ahead and do the quadratic formula on that, solving this piece, because we know the 2 is not going to give us anything. So -3 plus or minus the square root of 3 squared minus 4 times 1 times 5 divided by 2 times 1. So that is -3 plus or minus 9 minus 20 is -11 over 2. And so that means our other solutions are, I just put the I in the front like that. And so I can go back to my other page where I had my answers, and then I'll say -3 plus or minus I root 11 over 2. And I'm done. That's the end of the video. I'm so sorry.